What I want to do today, though, is in a sense, I'm going to treat you guys like a business, because you are. I'll show you, if you will, how I do sort of our business for aWhere, because we have also clients that we need to inform of things. And in many ways, it's a very similar concept. So the map you're looking at is actually today's downloaded file from, it's dated 5/26 because it was posted yesterday, and today's will be posted later today, meaning it has data from yesterday. So this is data that's 1 full day old. And you all know how to do this, right? You've seen this idea of, you go to the aWhere apps page, okay, and you log in. And when you log in, if you choose the interactive maps, it will take you to this. It defaults to East Africa. Get the data here is right on the upper right. You choose the region, you choose East Africa, you choose Uganda, and there's the 5/26 file. And you can see this is 5/26. Guys, this is easy. If you click this button, it downloads. So now I have it downloaded right here in my downloads. There it is. I can copy that file and I paste it. In this case, I pasted it into my East Africa Uganda folder, and it's important to organize your folders. So if I go to my data folder here, you can see there it is, 5/26 Uganda, and then you see 5/26 is open, is unzipped, right? I'm not going too fast, guys. Tell me when you're like, I don't know how to do that. This is just unzipping a file that I just downloaded right there, Uganda 5/26, there it is, and I unzipped it. Then the first thing I do, this is my workflow. The first thing I will do is I will go to QGIS. I will hit this button right here, and it's going to say delimited text. And all I'm going to do is load one of those, the CSV files that I just opened. So I go, this is the way I organize my folders. So this is my C drive. You can see my main folders. I have something called work projects. As you can see, I do work all over the world. So I'm going to go to Africa East. In this case, I'm going to go to Uganda. Later, I will go to the NAC folder, but I put the data for Uganda inside Uganda. So I go to data, and there are the files I just unzipped. And right now I have loaded the past 30 days. So let's load the forecast, the next 15 days. I want to make sure it loads as a WKT as opposed to points. So I hit add. There you go. So now inside of QGIS, I have the forecast that I just downloaded, okay? And I come to the QGIS, I double click it, I'm on symbology, I choose styles, I hit load style, click here, and it will take you, and I have a lot more styles than you have. I have different reasons for that, but no problem. There's my rainfall style, because I just want to look and see how the rains are in the forecast. In my case, I have to change this, but no, again, no problem. You just choose CSUM-PRE, the cumulative rainfall. You hit apply, and voila, there is a rainfall map. Now I'm going to turn off it looks like there's a map underneath it. Yep, right there. So here is the forecasted rainfall for the next 2 weeks. And as you can see, the bulk of Uganda is in this lower category. You can tell the category by just choosing this button up here for information. And I click, and it'll grab a cell, and it'll say 8.4 millimeters. So in the next 2 weeks, over most of Uganda, this color that you see, this, it's this 1 to 10 millimeter color, is pretty low rainfall in the forecast. Now, what you're also seeing are these red dots. And Rona, I want to thank you for the file. I'm going to show you all. This is what Rona sent to me. This is the location of basically your cooperative customers, right? These are all your guys. And she has the latitude and longitude. Now, I will tell you this. There's one trick. Now, this you really need to do right and have a fundamental feel for what I'm about to do. So this spreadsheet, the way it's organized, is not machine readable. In the first place, it's a spreadsheet, XLSX, okay? This is Excel. And Excel allows you to do this kind of stuff at the top and this kind of stuff. So you have 3 different rows here that are kind of the title of the spreadsheet. So what I did is I just took this exact spreadsheet and I made it look like this. See, so what I did is I actually deleted these first 2 rows, and then I just took the 3rd row And you can see parish, latitude, longitude, sub-county, and district. Maybe I should make this a little bigger, just a second. But this is important because this is machine readable. And these are just things that you have to know how to do. Then there's some quirks, and it's just because R is case sensitive. R is so powerful that the letter L, little l, and the letter L, big L, are two entirely different pieces of information. So we have to make some defaults. So in aWhere, we have decided that for the key column names that we're going to use, we only ever use undercase. We don't use capital letters. We also, because the word location can mean a lot of different things, we have decided that we don't call a society name, we don't call anything. If it has a latitude and longitude, we use the term place_name, place name. Also in R, you want to avoid spaces, even in your file names, which you already did. You have lokes_NAAC_members. That's perfect. All right, then you notice that I changed latitude and longitude from uppercase to lowercase, and that's all I did. I deleted 2 rows, renamed a couple of columns. I decided to move this column number over just because I like personally to have place name as the first column, and I'll show you why in a moment. And then so I did all that here. I deleted the lines, I rechanged the name, and then I just did save as. I did file, save as, and then you choose this lower button here, and I just saved it as a CSV UTF-8, just the standard comma delimited file, okay? And I'm going to, by the way, I'm going to email you all of the things that I'm running today. I'm just going to send it to you, and hopefully you can just start to run these files yourself. Okay, so I have this file called loknacmembers.csv, and back to QGIS, I literally went here, clicked the same button, delimited text. In this case, I navigated to the folder NAC. So I went Work Projects, Africa East, NAAAC, and there you see the lokes_CSV file, okay? Excuse me. And so I saved that, or sorry, I loaded that file, and what appears are these red dots, all right? And what I then did is I said, well, okay, I mean, it's good to have the red dot right here. And let me move it up. I should have these things, hang on. I'm just adjusting the order of the drawing, and these things should be at the top because I want them always on top. Okay, so now so I'm going to do this part quickly for that reason. So what I did is when I loaded it, I then made a duplicate of it. And in the duplicate, I put the names. So now you literally are seeing this exact spreadsheet that you sent me, slightly adjusted, and you're seeing this column, this place name column, on your map. Now, I'm looking at the forecast, but what I also want to do is I want to look at the last 30 days of the same file. So it's the same one, the same zip file, I just have it already ready. Now, this is the last 30 days, P/PET. What's interesting about this, and let me turn off the labels. What's interesting is quite a few of your cooperatives are kind of in light green, which means the water stress of the last 30 days is unlikely to be acute. But down here, there's a couple of places that are kind of in this sort of redder area, a little drier hole down here in the southwest part of Uganda. So what I'm going to do is I'm just going to show, this is my workflow. This is exactly what I would do. I would look at this and say, oh, well, I wonder which ones of these I need to look at. So if you highlight, you can choose display the information, and I can click here. And this is telling me this is the Kamwenge Tukarere Hamwe Grain Producers Cooperative. And you see the latitude, longitude. That's like just good to know. Okay, so I know the latitude, longitude. Now you can see where I'm headed, because now I want to diagnose this. I want to understand better what's really going on in this part of Uganda. Okay, and so you can see that there it is, the grain producers. So I'm assuming that this cooperative headquarters is here and that there are farmers around there. And some of these farmers have had some pretty dry weather, relatively speaking, last 30 days. So this is where R gets really interesting. So you can go back to your apps, same login. you can choose weather apps, right? And this is, you all have done this. We've showed this before. So now I'm logging, I'm back into my weather apps. This is online. It's already available to you all. I'm going to choose climate chart. You do have to let it load. And if you recall, I know the latitude longitude of that site, remember, because it's in the map, but it's also right here, guys. I mean, this is right there. That's the latitude. See that latitude longitude? I'm just going to go to, this is my workflow. I'm going to go to the climate chart. I'm going to get my key and secret, which are down here, right? I can just click here, and that's my key. I can come up here to the key and load it. Okay, now the latitude I'm going to load is directly from this spreadsheet, right? Right there. The latitude says 0.188. So I just type right here 0.188. And the longitude was 30.45. Okay, the location name, I'm not going to spell this out totally, but I'm going to write CAMWENGE. So that just to remind you. Then what I want to do is I want to look at kind of maybe just since about February, right? Just kind of take a look at the weekly rainfall and temperatures since February. And we need to make it 2021. Okay, that's for the long term, or the long-term level, that's fine, but the 2020 is long-term. And then I hit submit. So this is actually an R script that we have, it's called a wrapper. We have wrapped it in something called Shiny, and it's on our website. So you can do this right now. There's nothing, I mean, everything I've showed you so far is QGIS and the online tool, and it's going out and it's pulling from our API, and it's going to give you this chart that will help you diagnose the weekly rainfall and the temperatures for this location. All right, so you look at this location and you say, okay, this gold line is the long-term normal rainfall. So it kind of peaks early in April, and sure enough, they got some pretty good rainfall. And then it kind of starts to fall down. But look at that. They actually are wetter than normal slightly. No rain the last week and a little bit there. So probably these farmers, the last 30 days, it's like that's a lump. It's a quick indicator. It's not always 100% illuminating what's going on. But for this particular location, I would suggest that the rainfall is not too bad at all. In fact, it's slightly above normal. So this is a normal drying end of the rainy period for this part of the world. So now you know that, but let's keep digging in. The reason why I want to say that is because of this. So let's just say, okay, there's some farmers out there and you want to send them a forecast. This is where R gets so interesting. So if I go, so I'm on the website, now I'm going to go part of my workflow, I'm going to diagnose what's going on there. So I'm going to click R. Now I'm going to send you all 3 of these R scripts. Now, hopefully you've installed R. You have to install these aWhere chart and aWhere library, right? You only run these once. Once a year or so, you might have to update them, but you only run these once. Then these are the packages that this script needs. You have to install those. You can also use the format that I'm showing you here. This is just R. And you do not need all of these things unless it asks for it up here. But you can also, rather than installing them one at a time, you can actually take all these out. You notice that they're in parentheses, right? And you can take that name of grid extra. You could just do like this. This is just the way you work in R. Come down here, go like that. Go like this. I'm just sort of showing you how R works, guys. And then take GTable. And then you have to remember the syntax. You have to put a comma, and you have to do a quote. And then you paste in what library you want to install. We're going to get them. So you could do, this is just to show you that R has many ways of solving it. So you can run these individually by doing this, or you could run this one line of code and it will do them one after another. The point is, once you're installed, well, then everything above this line you don't have to worry about. You come down here, but you have to load your library. So these are all the libraries. See, there's aWhere API, right? You installed aWhere API. Here's the aWhere charts. You have to download charts, et cetera, et cetera. Okay, so I'm going to run these. And you can see down here, it's already loaded, but it doesn't matter too much. So I'm just running them to make sure everything is loaded. All right, now this, you have to create a credentials.txt file from your key and secret. You just paste it into a text editor and save it. And I think we have instructions for that on how to do that online as well. So I have to run this line of code, and now I have a token. And the token means that I'm accessing our API. Now, on my computer, I have a folder called Work Projects, Africa East, NAAC, right? And that's what we were just looking at here, and there you have it. That's what I have on my folder. What you have, you can do it your way, but you have to put these things somewhere. I would suggest, depending on your job and your role, that you would have a folder for like a project where you're sending these kinds of data, perhaps these forecast data, to some of your cooperatives, all right? So now I have to set a variable called working.dir to that folder, and then I set it, the working directory, for R by running the command set working directory. And if you run get working directory, down here it tells you, yep, I have the right working directory, okay? Now this one, you only have to run once, but if you run it again, it really doesn't matter. It's just gonna create output CVS for you. It's really cool. It's literally creating a folder for you, but if it's already created, it won't hurt it. So you could just go like that and run it again. Okay, this is the old way of running this script. So some of you may have seen the script before. All right, what I've done is I've said, wait a minute, I don't have time to run it one at a time, typing in the latitude, longitude, because I have.
John, can you expand the window a little so we can see better? It's a little hard to see.
Oh, I'm sorry.
Thank you.
Yeah, do that. And I don't know how to actually make the view bigger. I wish R had that way, but I don't think it does view. Let's see. Oh, well, maybe it does. Zoom out. Whoops, wrong way. Zoom in. Oh, it does. There we go. That's a little better, yeah? You can kind of see it.
Thank you.
All right. Oh, that's better. Thanks, David. I apologize for that. All right, guys. So once again, you know that I have the spreadsheet. Remember, I started with this idea that Rhonda sent me the spreadsheet. All I did was trim it out, make it a CSV file. So what I want to do is I want to load this spreadsheet, literally .csv. It's stored in the folder called NAC. It's right there, .csv. Okay, so I'm telling R, go to that folder and open this particular file. And it's a two-step process. Again, I'm making a variable called locations_file, and I'm saying make it equal to that particular CSV file. And then this is going to read the CSV file and put all the data into something called a data frame that we call locations. You can call it anything you want, but that's what I'm calling it. So now watch what happens up here in my environment. When I run this line of code, there is now a data frame called locations. Now here's a quirk. This is just something that happens. I'm going to open this up in R. Location. See, it looks exactly like the spreadsheet, right? It's called the data frame inside of R. But look at this weird kind of I with an umlaut and two dots in front of place name. Now, I don't know why this happens. It doesn't always happen with CSV files, but because it happened, and it happens every time I load these files, this is a command called names. I'm telling it, go into the data frame of locations, go to column 1, and make it say place names. So look at this. So there's locations. It's got the weird characters, and that will mess up R. R is very, very specific, guys. By running this line of code, and I open up locations, you see it's just place name now. So all I did was change the name of the column. I could change it to anything I want, but since I know I needed to say place names, that's what I'm going to do. All right, so now here, we're almost done, guys. That's it. I am setting up to run forecasts. So the first thing you do is how many days of forecast do you want? So for now, I'll just do 3. Now, here is a choice. This is very simple, guys. Okay, you know that this pound sign tells R to ignore anything to the right of it on that line. So you can see there's an error here because I have 2 for next loops, but in the end, I only have 1 closure of the loop. And the reason for that is that I know that right now, I want to look specifically at what's going on here in Kamwenge. I just want to look at that particular location for the forecast, okay? Maybe you know, I'm responsible for this particular region, and I know that those farmers are right at they're not, but let's just say they're right at about a time to plant, and I want to send them a forecast right now. okay? So what I do, you're gonna think this is real obvious, but inside location, see this number over here? It's obviously the row number. I know that Kamwenge is row number 5. That's all I know. I mean, I know it's 5. So I can say, do a loop, but it's a loop of 1, go into locations, grab number 5, and run the program. So I'm gonna go here and hit run. Now watch how fast this is. When that's done down here, look what just showed up in my NAP folder. Remember, I set the folder. So here is a forecast I literally just generated. My time here in Denver is 9:23 a.m. And here's the forecast. Okay, now it stores, it's 5:27. I'll explain some more things. It stored the forecast for you all from this morning. And since I know it's in your evening, for this particular location, there's a chance of moderate rain this evening. And the chance falls off a lot at night, but tomorrow, there's a pretty good chance of some rain. So these farmers tomorrow in the morning, less so in the afternoon, but tomorrow evening, there is a chance of rain. So this little graphic, I mean, and it's tiny, right? If I go, I'm using Windows, if I go here to Mac, I'm telling you, this thing is 34 kilobytes. So if I wanted to, I could go like right mouse click. I want to send to a mail recipient. And it's going to open this, and I could type, I think it's Rhonda, right? Whoops. No, I don't have Rhonda in my note, but I could send it to David. How's that? I could send this to David. And that's tiny, okay? 104 kilobytes is the whole size. And I'm done. I have created a forecast, guys. I literally right there, that fast, created a forecast. So this is where R gets really kind of cool. Okay, so we've run it for 1, and I can kind of go through the code. You never have to touch the code though, guys. It looks like a lot of stuff, but I can tell you that I need to pull the latitude and longitude out of locations, and I need to pull the latitude column, and the I says what row, and of course the row in that case was 5. But if I come up here and I put a pound sign, I can now, this will go away, I can now run all of the locations at once. It'll just through it. So it's going to pull the latitude and the longitude from row 1, right? It's going to go 1 to the end row, the number of rows of the data frame location. Then it goes and it loads something called forecast 1. It's just a data frame. It loads it by going to the aWhere API, and it pulls the forecast for that latitude, longitude. It takes today's date, which is reading your system. It literally reads your computer's date. Then it takes today's date and it adds the number of forecast days, number of days for forecast, which I made 3. And then it says block size is 6, so it's going to do 6-hour blocks, and this has to stay this way. So don't change this, because this is a graphic that's expecting it to be in 6-hour blocks. And then this use local time means it's going to read your computer's time, not UTC. It's just a way of, it's an attribute, if you will, of forecast, okay? This is just, I'm shortening it and so forth. And the reason why I'm shortening it has just to do with making it a little prettier. So when you look at this graphic, it says latitude and longitude with only 3 decimal places. Whereas in the spreadsheet, it has 4 or 5. In other words, I'm just cleaning it up. I'm making it look a little nicer. And that's the only reason why I'm doing that. Okay, so then you can see I pull out something called location name. Again, goes to the data frame locations, and it pulls out place name for row I. And this is just the way R is programmed, but you don't have to touch any of this, okay? But if you look over here, you notice that even though I only ran it for 1 place, here is the forecast data frame. This is what the API pulled, what you pulled down. If you open up that, look at the detail. So there's a conditions column, there's a conditions code, there's the end, the beginning and the end time, which is hourly data, guys. And the hourly data, there it is. That's actually hourly data from the API. That's all you did it just by running that 1 line of code. It created a forecast data frame. Okay. Then it says, let's subset the forecast data frame and select certain columns. So then you can open up the data frame of this. And these are just like spreadsheets, guys. This is exactly what it looks like. Only now we've summarized the time string to something that's legible English. And here you see the amount pre is rainfall, that rainfall we looked at, the chance of rain, and the conditions text file. So this is very systematic. So we create that sub, we do some things here about numerical columns, etc. We shorten the column names so they look nicer inside there. And these are just things that are going on in the script. Then it takes this and it wraps it so that it labels things correctly, etc., etc. Then it reorders things, makes it pretty. And then this bit of code down here is going to take the data frame and make it a PNG file. And then it writes the PNG file and you're done. So watch this. So you know that in Rhonda's spreadsheet, there are 32 locations. Row 33, because row 1 is the title. There are 32 locations. So if I go back to locations, there they are. There's 32 locations. So let me show you. And we'll do this, let's see, we'll do it this way. We'll open up this, because this is where they're going to be written to. This is how fast it can go through and do all of these things for you. So if you have a person that you want to have send the forecast out every day, every third day, doesn't matter, via email to every one of your cooperatives, you would just literally, this is all you do. You would start up here, you'd load the libraries, you get your API token, you'd set the working directories correctly, you would read in the file, you would come to row 79, you'd hit run, and you're done. And what's going to happen is it's going to start writing. Look at that. They're showing up. See them all showing up? So it is literally pulling from the aWhere API and writing a forecast JPEG for you. That's what it's doing. And I can open up any one of these, and it's going to say latitude, longitude, and there's the forecast, etc. So there's a high chance of a small amount of rain, high chance of some rain going on right now at Bukolo Oilseed Farmers. Oh, that's
now
clear.
that you have the list for these institutions that we work with, our members, can you generate information after you have finished doing all the information, inserting it into the system? Can you generate the information at a go, or you do one at a time?
Well, okay. I'm not sure exactly what you're asking, but what I did is I did both. The first time I ran this, remember, I ran this line, and this said, remember, I had this as number 5.
John?
Yes?
Okay. Now, like, for example, you worked on Tokolele Hamwe. Then you worked on Bukulo. What I'm asking is, now all the 33, can it generate information for all the 33 at a go, or you work for one at a time?
Okay, again, I'm trying to address your question. I'm not sure I fully understand it, but okay, we've loaded all of your locations. You get that, right? And R is very powerful. You can choose to run them one at a time by just picking row number 5, right? Location number 5. You could pick number 11. You could pick 11 through 14. Or you could run them all. And the way I ran them all was, all I did was run this line of code right there. I just ran that line of code, and it generated all 32 of the PNG files. See them? They're all there. So I'm not sure what your question is, because I ran all of them at once. Boom, one go. It took less than 60 seconds. And so everybody had a forecast in one go. Does that, am I addressing your question?
I think you have really answered the question if I got it right.
Okay, because I'm going to send you exactly the forecast for all 32. That's what I did right there. You see them all generated right there. Okay. All right. So remember, as I was saying, remember this. So here is this chart that we generated one time by typing in the latitude, longitude, and it generated this chart. Now I'm going to show you the same R script, but running in R is called, see, this one's 3A. It's the first one you do, right? Remember, workflow, QGIS, pick your area. 3B. 3B is the climatology chart. So let's go up to the top. There's some information here to help you out. You have to have things installed. You do not have to install it a second time. It just happens we put it here in case this is the one you started with, okay? You have to load the libraries. Now you may already have loaded them, but it doesn't matter. So I'm just gonna load the libraries. And you notice that only one shows that it needed to load. Okay, then once again, I could go get another token, but my token's probably still active. You notice I have lots of working directory things here, okay? Because that's how I do it. This is my working. I was doing some things for a colleague in Yemen, working in Brazil. But this is the one I need to run. And see, if I go get working directory, I know that it's still in the NAC one. I actually don't have to change anything. But if you start with this one, you need to run that code, boom. Look how fast this is. This will create more subfolders if you need them, but it won't hurt if they're already there. Once again, I've got this locations file. So you could have many different location files. You just choose which one you want. So I'm going to run that one. I read it in again. And once again, I read it in again. So it still has that goofy thing there. So now I'm going to run the same line of code to make it say place names. In this case, I have to set the long-term normal as years. Now here's for this one, I'm going to run it from February, just like I did online, but I'm going to run it through the 14-day forecast. So I'm choosing sysdate plus 14. I could do sysdate -1. I could do this. I could do a fixed day in. It doesn't really matter. Then you combine them, okay? I'm going to set the y-axis to be, I'm going to make this a little smaller because I know that the rainy season is kind of nearing an end, and I can hit run that, and now once again I have a choice. I can run one or the other. If that red line is there and I want to do them all, you have to put the pound sign, okay? But for right now, just to do something quickly, I'm going to run one. I'm going to run that chart that we just made online, but I'm going to run it inside of R. So I do this, and it's running through, it's going out on the API, it's requesting the data, et cetera, et cetera. Once again, while this is running, I'm generating this chart without the temperature because I told it not to. I said, I just want the rainfall. And what it's going to do, in this case, it's going to put these charts into the chart folder. And I'll show you where I told it to do that. So right now it's empty, and it's going to put this chart into the folder. So this is still running. It's just going to run it for one. There it goes. That's fine. It just has a, okay. And so here we go. And look at that. There's the chart. You see, it's the same exact chart that we saw online. It's just not quite as messy because I told it not to do temperature. Okay. So that's all it took to run that chart one time inside of R. But what's even makes this faster is doing exactly the same thing that I did for the forecast. I can take this out, and I'm not going to do this because it would take too long, but if I run this line, it'll produce that chart for all 32 cooperatives. That's R. That's what makes R so powerful. Once again, latitude is being pulled out of the location file. Location name is pulled out of the location file. The data frame weather DF is just a result of running from the library aWhere charts, the function generate aWhere dataset, which has all of these things as necessary inputs, okay? And the point is you can come up in this environment and you can see that I've got a weather.df folder for 130 days of 49 variables. There it is. And you might ask, well, wait a minute, I actually want to look at that data. Well, guess what? When you come down here, all this code is just doing things for you, right? One of the things it does, though, is it's going to write to something called charts, that chart, right? That's what you're seeing here. This line of code cleans up the weather DF. It pulls out very specific columns. It actually now changes the name of the column from GDD.amount to GDD. It changes relative humidity.max.average to relative humidity max average. So that's all this code is doing for is just changing the name of the column. Then I round the variables just to make it look a little neater. and it writes the mini data frame to a file inside of something folder called output CSV, and it keeps the same name as the chart. So look at this, guys. This is kind of important. So I'm in my chart folder, and there's the chart. If I go to my output CSV folder, look at all of them. I should have deleted these, but this is the, right there. There is the chart I just created. I can delete all these other ones because they were written. Now, I won't worry about it. That's the forecast information written as a file. But here is the daily data that was used to produce that chart, but it gives it to you in a nice, neat order. So that's actually daily data, guys. There's growing degree days, there's potential evapotranspiration, there's the rainfall, there's the relative humidity, there's the solar, here's the maximum temperature, here's the minimum temperature, there's the wind. So it's doing that while it also made that chart that we saw right there. Okay, now, excuse me. One of the things in my workflow, when I look at this and I'm saying to myself, what do you really see? This isn't terribly obvious, by the way, but there's a little bit of a drawing pattern here at the end of May, right, into June. Remember, I told it to do the 14-day forecast. That's why you see there's a little bit of rain in the forecast. But I am curious all of a sudden. Let's run one more script, but let's look at the trend over the last 16 years for rainfall in May. All right? And this is the other one I'm going to send you. So I have just run the climatology chart. I've ran it for one location. You could run it for all the locations, literally. And you can see I have different choices down here. You could get 13 to 19, literally rows 13 to 19, okay? 13 to 19. Or I could just run all of them, or I could run one of them. And that's what I ran. So now what I'm going to do, as part of my workflow, I've mapped it. I said, what's going on in this particular part? It's about normal. It's not a huge problem. But let's look at the trend. So this is the other tool. This tool is also available to you on the climate trend. But again, when you run it inside of R, you can run all of them. You might have to go get a cup of coffee if it's a big list, but you can run all of them. So this climate trend chart is something I'm going to send to you all in the R script. And if I go to my R script for the climate trend, once again, there's some things you have to have installed, but they're already installed, okay? So once again, there's some libraries you have to load, and you just want to make sure they're loaded, and they're all loaded. You've got to get your credentials, and we already know that. We already know what our working directory is. I mean, all of these are the same, but you might start with the trend chart. I mean, you never know. Anyways, I can load that same exact file, but it's already loaded, right? So I don't even need to do anything. Then you come here and you say, okay, let's do regression line. You notice I have it set. I have it set from April 27th to May 26th, literally yesterday. I want to look at kind of that period of late April to late May. And it has to be this form, guys. It has to be 420-27 or 1-15. Anyway, so I'm going to run these lines of code. And then when I come down here, I'm going to do the same thing. I'm going to run just for that particular location that we've been looking at, or I could run all of them. So I'm going to run this. Now, while this is running, you're going to see it down here. It's starting with 2006. It's getting the data for just those 30 days. Then it's going to go 2007. So this takes a little time, so no problem. While it's doing that, I'm just going to show you a little bit of stuff inside the code. It looks complicated, but it's very systematic. That's what makes R so powerful, is that you can repeat this for all 32 or 13 through 19 or 18 through 21, and it will generate the charts that it's about to show you. So if I go back to my Explorer and I'm in charts, you're going to see 4 charts pop up when this particular script finishes running all the way through 2021, okay? So it pulls out the place name, the latitude, longitude, there's a counter, it's looking for the sequence 2006 through 2021, but it checks, because if you want to run a trend for August, obviously there is no August 2021 yet, it will skip it. It's smart enough to know, don't bother with 2021, okay? So then it's going to pull out, it's going to pull the data and see if Y starts at 2006, it does this, or it does that. This is just the coding, guys. And I would be delighted to tell you, you can work your way through this if you want to, but that's the way that's what R does for you, all right? Then it's grouping things, it's creating a regression chart, it labels the chart, and it generates the chart. That's all this script is doing. It's kind of complicated. It changes the font size. It changes things that you can really control how it labels the chart. Obviously, this is pretty skilled R scripting. I can't do this, just so you know. I had a technical guy to do this. But running it is easy. You don't have to even look at this script. You notice I already hit run, and it's about done. So let's go over here and watch these charts pop into the folder. See, it's 2021. When it finishes 2021, it'll generate the chart. And the purposeful intent of this is that you may have farmers in that part of the world, and this is what the trend is, if you will, for rainfall for that particular chart. So you can see the rains are really bizarrely, the CV of the rains for that period is pretty high. They've been as low as 50 millimeters for that 30-day period, as high as 170. The last 3 years have been below average, you know, because the mean for 16 years is 108 millimeters. They got 100 millimeters last year in 2020, but this year they're down here to about, looks like about 65, okay? So that's the trend chart. It's a mild drying. But here's where things get interesting. The maximum temperature, it's not a huge increase, by the way, or minimum temperature, has gone up about 1 degree. The trend is pretty clear, especially these last years. Look at that. That trend of warmer nights is very real. Here's the maximum temperature trend. And again, it hasn't gone up absolutely very much, from about 25.9 to 26.4, so 0.5 degree, not very much. But that has a PET calculation. And if you look at PET, you can see this is where things get sticky. It's dropping below 1. And the last 3 years, it's been below 1. And this year was about 0.75, which is what we noticed when you go back to QGIS. See, that orange, if you look at the map over here, is between 6 and 8, but about 0.75. So you have symmetrical data, right? The map data was the last 30 days. The chart that I'm looking at is the last 30 days, because I actually chose the dates specifically, late April to late May. And you can see it's about 0.75. But that trend, which is not significant, okay, but it is a trend of getting drier. And in some parts of Uganda, you're going to find trends that are quite explicitly more difficult to deal with, all right? All right, so that was kind of what I wanted to show you in this training. It seems like a lot, and I totally appreciate that, by the way, because when I got started, it felt overwhelming. But I want to go back up to the top of this one. If you recall, all I did to get the trend chart was to open this up, load my libraries, load my credentials, go to the working directory I want to do, and that might never change. You may use the same directory for this stuff. Load my file that has the locations. That can change. Maybe you get some new members, right? And you can run it. Choose which period we want. Give it a nice, clear title, because that's going to be on every chart. And then either run it for 1, 5, 6, 19, or all of them. And if you're going to run all of them, you have to put the hash mark, guys. It won't work. You have to make it so there's no orange dot. But okay, you can run it for all of them. And of course, this is going to get really full, and it'll take about 15 minutes of charts. But you'll have it for every single location by just running that one. So I'm going to stop there. Let's take some questions and make sure that, because I'm going to email exactly those 3 and the locations file. And all you have to do is get your credentials to work by pointing R to the folder where the credentials are, make a folder for your work, and try to run these scripts. You don't have to do any programming other than get it installed and tell it certain variables, certain things like that. So let's take some questions.
John? Absolutely, to me, there's no question. But I'm so in love with this tool. All I have to do is now to follow your recordings, to follow your teachings, to make sure that I master this. I'm one person who loves doing things that others do not know. I know this thing is not here in Uganda. I am going to learn it, and I have to make sure I feel sweet on others who do not know while I'm teaching them on how these things are done. Otherwise, I'm grateful for this. It's a very huge opportunity for us to extend success to our farmers. It's a very good tool that nails everything in 1 microsecond. Thank you.
You're welcome, Rona. We're very happy to be working with you guys because I want you to send me your questions too. But here's the last thing I want to make sure you understand. If you
see, John, come when we are trying. When you're trying to use R, that's where the questions come from. Because somehow, someone will feel like there's something that maybe it's not working out. So I would request that once we hit on your WhatsApp groups, kindly you be available for us to answer those questions.
You can send me emails as well because I don't know if I'm in the Uganda WhatsApp group. I'll have to double check. But here's something you can try. So this is just Chrome, right? This is my browser. You see it's talking about ggplot. It's because I sent a question to Chrome yesterday looking at this as how to make the subtitles and captions. Let me show you something. If you type the letter R, this is just into Chrome or any, whichever one I use Chrome, okay? And you see what I wrote? How to make 2 title lines in ggplot. Seriously, guys, if you were making a chart and it didn't look right, you could say, well, how do I change the font size? Well, I wrote how to make 2 lines in ggplot, and I hit return, and somebody has already asked the question. So this is like the ultimate tutor. If you have any questions, you just literally type the letter R and say, how do I change a data frame column name? And it will give you 4 or 5 ways of changing the column name. I mean, it's unbelievable, you all. I mean, before you ask WhatsApp group a question, I would encourage you, ask your questions just to Google. Just ask it, because whether it's a simple question or a complicated question, how you could say, how do I read a .csv file? And look at this. It will tell you, reading CSV files, programming in R. I mean, you can even ask it for tutorials. R, beginner tutorials. And there's lots of them. Look at this. Look at this. And they're recorded. It's unbelievable, guys. There is such a huge community of R users. You can teach yourself R. You do not need to have us or anyone else. I mean, sure, at the beginning, it's really nice to have someone you can ask. But that is the truth of it, guys. Just ask Google. Uncle Google, the answer's there. You can figure it out. Seriously. Okay, other questions, comments?
I think it has been a good one. And now, when we look at charts, maybe the other thing that we shall look at, that I'll request maybe, that is if we fail to get it from Google, is making beautiful charts using R, especially when we want to make bulletins to disseminate the information to the farmers.
Yep.
If we fail to get that on Google, I think I'll get back to you on how to make beautiful charts that are really enticing to the viewers, to the readers.
Absolutely, guys. And QGIS, we can help you with the QGIS. There's tutorials. Because I think for your bulletins, you're going to want to have, like, for these guys in the I'm going to call it the southwestern region. So if you look at this map, you're like, yeah, but the font is too tiny. What do I do? Well, you go into QGIS and you choose label and you increase the font size. I mean, this is not complicated stuff, right? Voila.
True.
Okay, so then now you have a Western region map. You do a screen capture for your bulletin. You make the forecast. You put the forecast in. Maybe you make a trend chart. And you know how to do it because you have the names. You choose the column. You say run column 32, and then you run column 27 and a row, and you're done. And you have this beautiful bulletin, and you can run the forecast, guys. It updates every 6 hours. So if it's an important time of year with the rainfall onset or something like that, you can send them a forecast every morning or every night for tomorrow. Okay, and that's my workflow. That's how David and I do this. I mean, we make videos. David's learning to do these videos of World Weather Watch for the whole planet. And that's how we do it. We download our own data, we put it into maps, and he talks about it. We put charts in where necessary. We zoom into West Africa, or we zoom into East Africa, or someplace in Indonesia. Okay, and this stuff is powerful, and we're just getting started. So there's lots of things you can do. I will email you each of these 3 programs exactly as they are right now saved. So they're saved with your locations file and these other things, which I will also send you. And I want you to send me your bulletins. I want to see what you can do with this stuff. Seriously, I want to see that you can do it. And obviously, send us your questions. We'll try to help.
All right.
All right. Thanks, John. I'm going to stop the recording here, but we can continue with questions and we will follow up. Thanks, everyone, for participating.
Yeah, thanks, everybody. You've been great. And hopefully this will help you all really grow a good business.